now the second category of transmission media, that is unguided media. Unguided media actually transport electromagnetic waves without using a physical conductor. Normally these signals will be passed along free space. Okay, and this type of communication is also known as wireless communication. And here the signals are normally broadcast through free space and thus are available to anyone who has a device capable of receiving them. And unguided media use this electromagnetic spectrum in the range from 3 kHz to 900 terahertz. Okay, this is the frequency band used for wireless communication. You can see that 3 kHz to 300 GHz comes as radio waves and microwaves, and high frequency range 300 GHz to 400 terahertz is infrared, and beyond that we have this 400 to 900 terahertz, it is light wave. So these are the different frequency ranges used for wireless communication. And unguided media, signals can travel from the source to destination in three different ways: ground propagation, sky propagation, and line of sight propagation. Ground propagation with low frequency signals, that is below 2 megahertz, and sky propagation mid-range frequency, that is 2 to 30 megahertz, and above that we have line of sight propagation above 30 megahertz we have this. Okay, coming to each one in detail. First one is ground propagation. You can see that in this case the lower frequency signals, that is signals below 2 megahertz, the signals are traveling very close to the surface of Earth, right? Yeah, radio waves travel through the lowest portion of the atmosphere, hugging the Earth. And these low frequency signals emanate in all directions. We have an antenna here. Signals emanate in all directions, and that is from the transmitting antenna and follow the curvature. Signals follow this curvature of the planet, and how much distance they can travel purely depends on the power of the signal. Greater the power, greater the distance. And the second one is sky propagation. In this case, the signals are actually high frequency signals, right? These high frequency radio waves radiate upward into the ionosphere. Ionosphere is a little more distant from the Earth's surface, right? Where particles exist as ions. And these signals are actually reflected back to the Earth. This type of transmission is actually used for greater distance compared to our ground propagation with a low output power. And the third one is line of sight propagation. So very high frequency signals, those are signals above 30 megahertz are used for this sky propagation. Antennas must be directional. In this case, you can see that two different antennas facing each other, and either tall enough or close enough together not to be affected by the curvature of the Earth. And line of sight propagation is very tricky because radio transmission cannot be completely focused. That is the thing here. And these are the three different propagations for wireless transmission. And wireless transmission we can divide into two different categories or groups of signals. One is radio wave, microwave, and infrared waves. You can see one by one. First one is radio waves. Radio waves actually, there is no clear-cut demarcation between these radio waves and microwaves. Consecutive frequency ranges are within this radio waves and microwaves, and usually these are the electromagnetic waves ranging from frequencies 3 kilohertz to 1 gigahertz. Okay, that is radio waves, and between frequencies 1 gigahertz and 300 gigahertz we have the microwaves. And beyond this frequency range, it is better to classify these radio waves and microwave based on their behavior actually. And in case of radio waves, these waves are actually omnidirectional. Okay, and when an antenna transmits radio waves, they are propagated in all directions. This means that the sending and receiving antenna do not have to be aligned. That is the case here. Okay, a sending antenna sends wave that can be received by any receiving antenna. So this omnidirectional properties obviously have advantage, and at the same time it has a disadvantage. That is, what's the disadvantage? The radio waves transmitted by one antenna are susceptible to interference by another antenna, right? Yeah, that may be the problem here. And radio waves, especially those waves that propagate in the sky mode, can travel a very long distance. That's the main advantage of radio waves, and this feature makes this radio waves useful for long distance broadcasting, such as radio, AM radio and all. We are using this radio waves. And radio waves, especially low and medium frequencies, can penetrate walls. That is another advantage of radio waves. So that is why we can keep our radio inside our home and still receive signals from the antenna. Okay, so advantage here is that we can use this radio or any device which use this type of communication inside a building. We can keep an AM radio inside a building. At the same time, the disadvantage is that we cannot isolate a communication to just inside or outside a building. It can penetrate through walls. So there is no such isolation of communication. And the radio wave band is relatively narrow, just under 1 gigahertz compared to microwave band. And when this band is divided into subbands, the subbands also will be more narrowed, right, leading to a low data rate for digital communication. So compared to microwave, data rate will be minimal in this case of radio waves. And antenna use here is omnidirectional because the signals are of omnidirectional nature. Radio waves use omnidirectional antennas that send out signals in all directions. Based on the wavelength, strength and purpose of transmission, we can have several types of antennas. Okay, one type of antenna is shown here. Now if we look into the applications of radio waves, this omnidirectional characteristics of radio waves make them suitable for multicasting, right? So multicasting in the sense there is a one sender and multiple receivers will be there. So we can use this type of radio waves in AM and FM radios, television, cordless phones, paging, etc. These are the application. Now coming to the second type of wave, those are microwaves. So in case of microwaves, the range of frequency is actually from 1 gigahertz to 300 gigahertz. And the main specialty here is that those microwaves are actually unidirectional. That means when an antenna transmits microwaves, they can be narrowly focused. Okay, so this means that the sending and receiver antennas need to be aligned. Whereas in case of radio waves, there was no such restrictions, right? Here the two antennas, sending and receiving antennas, should be aligned. And these unidirectional properties have obviously advantage and at the same time disadvantage. Advantage here is that a pair of antennas can be aligned without interfering with another pair of aligned antennas. Yeah, there won't be any interference. And coming to other characteristics, microwave propagation is line of sight. Both the sender and receiver should be in the line of sight. And since the towers with the mounted antennas need to be in direct sight of each other, towers that are far apart need to be very tall. So if these two towers are far apart, they should be tall enough. And the curvature of Earth as well as other blocking obstacles do not allow two short towers to communicate by using microwaves. That is another drawback. And repeaters should be required for long distance communication. Using very high frequency microwaves cannot penetrate walls. So this characteristics can be disadvantage if receivers inside buildings are used, right? So that is another issue. So we cannot use in radio and all. Okay, and the microwave band is relatively wide compared to radio waves. Wide range of frequencies are there. So obviously the data rate will be more in case of this microwave. And use of certain portion of the band requires permission from authorities. That is another thing here. And coming to antenna used in microwaves, obviously they have to use unidirectional antenna because the signals communicate in a unidirection. Microwaves need unidirectional antennas that send out signal in one direction. We have two different types of antennas. One is parabolic dish antenna and the second one is horn antenna. Okay, you can see one by one. First one is parabolic dish antenna. So parabolic dish antenna is based on the geometry of the parabola. That is, every line parallel to the line of symmetry, that means the line of sight, reflects off the curve at angles such that all the lines intersect in a common point called the focus. You can see here, this is the line of sight, a straight line, okay, line of sight or line of symmetry. All the lines parallel to that line of symmetry, okay, you can see a set of lines, right? Signals, if these signals are traveling in this direction parallel to the line of sight, what happens? They reflect at an angle such that all these lines of reflections join at this point, which is a focus. Okay, so all these lines are collected, which are incident on this parabola, are collected to a common point called focus. So this is how this parabolic dish antenna works. Okay, so the parabolic dish works as a funnel, catching a wide range of waves and directing them to a common point, catching all the lines, all the signals incident on this long parabola, and collecting all those signals to this focus point. So this is how this parabolic antenna works. In this way, more of the signal is recovered than would be possible with a single point receiver. Coming to the second one, that is horn antenna. In case of horn antenna, it's looked like a gigantic scoop, right? Yeah, you can see here it is similar to a scoop. So in this case, how it works is actually outgoing transmissions are broadcast up a stem. Through this, outgoing signals are actually broadcast, and while the signals coming here, what happens is it is deflected outward in a series of narrow parallel beams like this. This will deflect it, and received transmissions are collected by the scoop. Okay, just like here, all the signals are collected by the focus. Here, received signals will be collected by the scoop. That is how the signals are collected and transmitted. So these are the two different types of antenna. Now, application of this microwaves, due to their unidirectional properties, they are very useful for unicast transmission, like sender and receiver only. They are used in cell phones, satellite networks, and wireless LANs. These are the main applications of this microwaves. Now coming to the third type of wave, those are infrared waves. The infrared waves which are very high frequency signals, 300 gigahertz to 400 terahertz are used for this infrared communication, and they are used for very short range communication. So coming to the nature of this infrared waves having very high frequency, it cannot penetrate through walls. So obviously these nature have advantage at the same time disadvantage. Coming to the advantage, it prevents interference between one system and another. And a short range of communication system in one room cannot be affected by another system in the next room. That is why we can easily use this type of communication in remote and all. Remote control for TV, right? Yeah. When we use our infrared remote control, we do not interfere with the use of remote by our neighbors, right? Yeah, that is one advantage of this infrared. However, the same characteristics made it negative also, because this type of communication is not suitable for long range communication. So very short distance communication we can use this infrared. And we cannot use this infrared waves outside a building, because the sun's rays contain infrared waves that can interfere with the communication. That is another drawback. Application of infrared is almost high frequency range, that is 400 terahertz, has an excellent potential for data transmission. For data transmission we can use it. Such a wide bandwidth can be used to transmit digital data with a very high data rate, very high band, very high data rate. And Infrared Data Association, such a community is an association for sponsoring the use of infrared waves, and they established a standard for using these signals for communication between devices such as keyboard, mouse, PCs and printers. We can use this type of infrared. For example, some manufacturers provide a special port called IRDA port that allows a wireless keyboard to communicate with a PC. And the standard originally defined a data rate of 75 kilobit per second for a distance up to 8 meters. We can use this wireless keyboard and all. The recent standard defines a data rate up to 4 megabit per second also they are offering. Infrared signal defined by IRDA transmit through line of sight. That is the only thing. The IRDA port on the keyboard needs to point to the PC for transmission to occur. Then only such a transmission is possible. Anyway, up to 8 meter we can keep the keyboard away. So these are all about wireless media. Thank you.